Alright, so let's go through the polynomial question. So the very first part, we are given 3x plus k, right? So they say that this thing is a factor of the polynomial as given. So of course, they ask us to show this part. So we are asked to show 2k cubed plus 33x minus 35 equal to 0. Okay, so how do we actually do this? Very simple. First, we must understand that 3x plus k is a factor. So meaning that you make x the subject, then you notice that I'll get x equal to negative 1/3 k. So when I sub in negative 1/3 k into all the x's as seen in the polynomial, right, you will actually get equal to 0 because it's a factor. So remember your factor theorem, you sub the factor into the polynomial, right, the remainder is equal to 0. So okay, so you sub in. So for example, you sub in the first term, second, third, and the fourth term, right, you will get something like this. So for the first term is k to the power 4. For the second term is 2 over 9k cubed. Third term will be negative k4. Then fourth term will be positive 11 over 3k. Then of course last term don't need to sub, just minus 35 over 9. Okay, then the next part you'll notice is that k4 and minus k4 will cancel. So what is actually left is the three terms, right? So for example, 2 over 9k cubed plus 11 over 3k minus 35 over 9 equal to 0. So the next part I will say normally I will just times 9 throughout. So I times 9 throughout. So this will give you 2k cubed plus, okay, times 9, 11 over 3 times 9 is 22k. Is 33k, not 22, 33k minus 35 equal to 0. So that is the very first part, A. Okay, then I will say for part B, right, 4 marks, show that the equation, this thing, right, 2k cubed plus 33k minus 35 equal to 0 has only one real root for all real values of k. So how do we actually do this? Very simple. First, you notice is a cubic equation, right? So what I want to do is actually to determine your factor of this first. So meaning, for example, you sub in, so for example, right, k equal to 1. So k equal to 1 is actually a factor. How do I know? Because you just sub in. So for example, 2 then 1 cubed plus 33 bracket 1, right, minus 35. So you do the calculation, you realize that your remainder is equal to 0. Means that k minus 1 is a factor of the so-called cubic equation as seen right here. Okay, the next step is actually to go from cubic to your quadratic. So meaning you use your LD, long division. So 2k cubed plus 33k minus 35, right? You do the LD, right? So for example, k minus 1. Of course, let's do a very quick recap of LD. So for example, always use the very first term, divide by the first term. So 2k cubed divided by k, right, will give you 2k square. Then minus of, so 2k square right here. So 2k square, you must also times minus 1, right? So minus, it's 2k cubed, not 2k square. So 2k square times k is 2k cubed. 2k square times minus 1 is minus 2k square. So of course, you minus off. So this will give you 2k square plus 33k minus 35. Okay, again, you need to divide this thing by k, right? So this will give you plus 2k. So plus 2k, right? So minus of, so 2k square minus 2k bracket. So of course this one 0 already, right? So this will be 35k minus 35. Okay, the last part will be this thing again. So for example, 35k divided by k. So this will give you plus 35. So of course, eventually the remainder should be equal to 0 because k minus 1 is a factor. So this will give you 35k minus 35. So of course the remainder will be 0. Okay, so from here we actually get the quadratic already. So of course, just think of one thing is that k minus 1 is the factor of your 2k cubed plus 33k minus 35. So okay, I want to check whether 2k square plus 2k plus 35, right? Can I actually get any real roots, right? Okay, this is where I need to go back to the very first chapter that we learned, or the second chapter, right? The real roots, the b squared minus 4ac. So to check whether how many real roots are there, you use b squared minus 4ac, right? Okay, what is our b squared, right? So it's 2 squared minus 4ac, right? So c is 35. So this will give you negative number of let's see, 4 minus 4 to 35. Okay, so this will give you about negative 276, which is less than 0, meaning that this thing, right, there's no real roots. So this one is no real roots. Okay, yeah, so if let's just say you put them together, so just now I do the factor theorem, right? So 2k squared plus 2k plus 35 bracket, then after that one of my factor is k minus 1, right? So k minus 1. So you do the so-called rainbow expansion, you will get back your so-called cubic equation of 2k cubed plus 33k minus 35. Yeah, so of course the only factor, right, they say show that this one has only one real root, meaning that what is the one real root? The one real root actually come from here. So this bracket right here, right, there's no real root. So yeah, that is how we actually show. So with this, right, you just say k minus 1 is the only real root. Of course, not to forget to show the b squared minus 4ac for this. Yeah, so because we must show that this one there's no real roots, so we must use b squared minus 4ac, you get negative 276. So there's no real root for this part. Okay, alright, that's how we actually do this question.